guys, this looks like a fun one. We're given 3 squares and the areas of those 3 squares. And I want to know what is the area of these shaded triangles. This is day 30 of the 2025 Advent calendar. We're almost done. In order to solve this one, I'm going to use all these notes. And if you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, for this square with an area of 20, we know the side lengths are going to be equal to square root of 20 because the side length of a square is always equal to the square root of the area. And same thing for this square, since the area is equal to 65, all the side lengths are going to be equal to the square root of 65. And then for this square with an area of 45, the side lengths are square root of 45. So now we already know the bases of the 2 shaded triangles. All we need is the heights. Let's draw this up to here and then extend it all the way over to here and then drop it down here. Let's label this H for height of this triangle, and we can label this V for vertical of this triangle. And now we can write a formula for the total shaded area. The area of a triangle is equal to 1/2 base times height. So we can do 1/2 of the base root 20 times the height of H plus 1/2 of this base root 45 times its height of V. This is what we're trying to solve, so let's put a box around it. And let's move it down here. So I'm not exactly sure what to do next, but we do have 2 right triangles here and here, so we can find the third side of each of those. Let's call this one A and this one B. And now we can do the Pythagorean theorem. It'll be A squared plus square root of 20 squared equals square root of 65 squared. And we can also do this triangle. It'll be B squared plus square root of 45 squared equals root 65 squared. And now to simplify these, the square root and the square are going to cancel each other out. So this is going to become 20. And same thing, this will be 65, 45, and 65. Let's smush everything together and let's get the A squared and the B squared alone. We can subtract 20 from both sides or subtract 45 from both sides. For the top one, we'll end up with A squared is equal to 45. And for the bottom one, we're going to have B squared is equal to 20. Next, we can square root both sides of both equations. Since A and B are positive distances, the square root and the squares can cancel each other out. So we end up with A is equal to square root of 45 and B is equal to square root of 20. Let's update this A to square root of 45 and this B to square root of 20. And now let's try to figure out what to do next. Let's clean things up a little bit, scoot this over and scoot this over. And from here, let's extend this all the way up to here and then complete this rectangle. And let's highlight the sides of the square inside of the rectangle. Since this inside here is a square, we know all the sides are congruent and all the angles are equal to 90 degrees. Now let's focus on this triangle down here. We can label this angle alpha and this angle beta. And then the sum of the interior angles of a triangle is equal to 180 degrees. So we know alpha plus 90 plus beta is equal to 180. And then right here, we know these 3 angles are equal to 180. So that means this angle is also alpha because alpha plus 90 plus beta is 180. And same thing in this triangle, since this is alpha, this is 90, this is beta. And that same pattern is going to continue making this alpha, this beta, this alpha, and this beta. And let's color in the 4 right triangles red. By the angle side angle theorem, we know that each of these triangles are congruent with each other. Anytime you have 2 triangles with 2 pairs of corresponding congruent angles and the side between them is also congruent, you know that the 2 triangles are congruent. That's the angle side angle theorem. Here's the notes right here. Now that we know that the 3 triangles are congruent, all their corresponding sides will be congruent. That's known as CPCTC. Corresponding parts of congruent triangles are congruent. So in this triangle, the side opposite the angle beta is equal to root 45. That means in this triangle, the side opposite the angle beta is also equal to square root of 45. And then we also know the side opposite the angle alpha is equal to root 20. So this side opposite the angle alpha is equal to root 20. And then this side opposite the angle beta is equal to root 45. And this side opposite the angle alpha is equal to root 20. And now we have values for the H and the V. This is the same thing as the H, so H is equal to root 45. And this is the same thing as the V, so V is equal to square root of 20. And now we have everything we need to finish the area formula. Let's give ourselves some room, and in the place of this H, let's plug in square root of 45. And in the place of the V, we can plug in square root of 20. The root 20 and the root 45 can be put under the same square root, so it'll be square root of 20 times 45. And same thing for this one, they can be put under the same square root. 20 times 45 is equal to 900, and 45 times 20 is equal to 900. Square root of 900 is equal to 30, and square root of 900 is equal to 30. 1/2 times 30 is 15, and 1/2 times 30 is 15. And now we know that each of these triangles has an area of 15 square units. And we can combine them together to give us the total shaded area of 30 square units. And this is the answer to our question. Let's put a box around it. In this given diagram, the total shaded area is equal to 30 square units. How exciting. And here's the last puzzle of the Advent calendar, day 31. We're given 3 equal squares packed into a bigger square, and it wants to know what is the shaded area. This is for sure going to be a fun one. How exciting.